All right, let's talk about Docker. It's a tool that has completely changed the game for how we build and ship software. It's incredibly powerful, but let's be honest, it can also feel a little intimidating when you're first looking at it.
So, if you've ever found yourself thinking something like this, trust me, you are not alone. It's a super common feeling when you first run into all the new lingo and the commands.
But here's the good news. The core idea behind it all is actually surprisingly simple. And in this explainer, we're going to demystify Docker and show you exactly why it's become such a must-have tool for any modern developer.
Okay, so to really get Docker, we first have to understand the problem it was designed to solve. And it's a classic, hair-pulling headache that's been bugging developers for decades. The infamous, well, it works on my machine syndrome.
You know the story, right? You spend weeks building something amazing, it runs like a dream on your laptop, but the second you try to share it with a colleague or deploy it to a server, everything just breaks. And why? Because their environment is just a little bit different. A different operating system, different software versions, maybe a library is missing. It becomes a total mess fast. And that's exactly where Docker swoops in. It offers this really elegant solution to that exact problem with its core idea, the container. Just think of it like a perfect, self-contained little magic box for your application. See, a container bundles up your application's code along with all of its dependencies. And I mean everything. The libraries, the frameworks, those specific configuration files, even system tools. This neat little package is totally isolated and portable, which guarantees that if it works inside the container, it's going to work anywhere that container can run. Now, you might be thinking, wait a minute, isn't that just a virtual machine? And that's a fair question. But not quite. A VM is, well, it's a heavyweight beast. It has to bundle a full copy of an entire operating system, which is slow to start up and just hogs resources. Containers, on the other hand, are unbelievably lightweight. They cleverly share the host machine's operating system kernel, which makes them lightning fast and super efficient.
Okay, theory is great, but let's get our hands dirty and actually look at the basic building blocks and commands you'll be using. To really wrap your head around Docker, there are a few key terms we've got to know.
So first up, we have images. The easiest way to think about these is as the static blueprints or the recipes for your application. Then, from those images, we create containers, which are the live running instances of your app. The whole show is run by the Docker daemon. That's the engine humming along in the background, and you control it using the Docker client, which is basically your steering wheel, the command line tool in your terminal. And finally, there's Docker Hub, which is this massive public library where you can find pre-built images for pretty much anything you can imagine.
Pretty much every Docker journey starts with this one command right here. When you type this in, your client tells the daemon to go find the Hello World image. It'll pull it from Docker Hub if you don't have it, and then spin it up as a brand new container.
And if you see this message, congratulations, it's alive. This means your Docker installation is working perfectly, and you've just successfully run your very first container. Awesome.
Okay, that was cool, but let's try something a bit more dynamic. With this command, what we're doing is telling Docker to pull a really tiny Linux image called BusyBox, and then inside that new container, run a single command, echo hello from BusyBox.
And just like that, you see the output. This is a brilliant example of the power and speed of Docker. A tiny, isolated Linux environment just started up, it ran our command, printed the result, and then disappeared, all in a fraction of a second. Just try to imagine doing that with a full virtual machine. No way.
So, using pre-built images from Docker Hub is great, but the real magic, the real power, starts when you begin creating your own. So let's move on and see how you can build your own custom application using a special file called a Docker file.
The whole process is actually really straightforward. First, you write a Docker file. It's just a simple text file that acts as the recipe for your image. Next, use a command to build the image from that recipe. And finally, you run a container from your shiny new image. So it's recipe, blueprint, running app. Simple as that.
And here's a quick look at one for a Python app. The from command tells Docker what base image to start from. In this case, an official one that already has Python 3 ready to go. Expose doesn't actually open the port, it just documents that the app inside is going to be listening on port 5000. And finally, CMD sets the default command that runs when the container starts up. See? It's really that simple.
Okay, so here's the thing. Most real-world apps aren't just one simple service, right? They've got multiple moving parts. And thankfully, Docker has a fantastic tool for managing all that complexity.
I mean, your application probably needs a web server, a database, and maybe a separate service for handling background jobs. Trying to start, stop, and link all of those containers together by hand from the command line, well, it would be an absolute nightmare.
And this is exactly where Docker Compose comes in to save the day. It's a tool specifically for defining and running multi-container Docker applications, and it saves you from what we all lovingly call command line spaghetti.
You define all of your services in one single, easy-to-read file called docker-compose.yaml. So here, you can see we're defining a web service, and build dot tells Compose to build it from the Docker file in our current directory. And then we have a DB service, where image Elasticsearch just tells it to go pull that pre-built image from Docker Hub.
And this is the real aha moment. With one single command, Docker Compose up, your entire application stack, the web server, the database, the whole shebang, it all just springs to life. This is a total game changer for local development. A new person can join the team, clone your project, run this one command, and have the exact same environment running in minutes. It's incredible.
Okay, let's just zoom out for a second and appreciate the massive impact this technology has had on, well, everything, and see where it fits into the bigger picture.
You know, this isn't some little niche tool. It is a fundamental shift in computing. To give you some perspective, way back in 2014, Google was already running over 2 billion containers every single week. The number today? It's got to be almost unimaginable.
Now, you're going to hear Docker mentioned in the same breath as Kubernetes all the time. It's really important to know they aren't competitors, they're partners. Docker is the tool you use for building and running the individual containers. It's the foundation. Kubernetes is the orchestrator. It's the tool for managing and scaling thousands of those containers across a whole fleet of servers. So you could say Docker builds the bricks and Kubernetes builds the skyscraper.
So, we've covered a ton of ground, right? From the basic problem of it works on my machine, all the way to running complex apps with a single command. But honestly, this is just scratching the surface. The power of containers